Alright, Algebra 2, this is the second video um, of the week for week of 420. Second video. The first video was about rules of exponents, simplifying those. No homework was at the end of that video because the homework's at the end of this video. So this one's going to be a little bit shorter, hopefully, and I just want to give a few examples. Okay, so let's take this one real quick. Number one. Call this number one. I have square root of 5 plus 3 square root of 5. Well, this square root of 5 does have a coefficient, a number in front of this. It's actually an invisible 1. So you can think of that as an invisible 1. I'm going to put this in red. Plus 3 square root 5. So simple. Can we add these? Yes, we can. They're like terms. Why are they like terms? They both have square root 5. Final answer equals 1 plus 3. 4 square root 5. Done. Okay, but this one, problem number 2, for example, they are not like terms because they do not have the same base here. They're not, that's a square root of 7, that's a square root of 5. Cannot add them. That's it as is. Okay, so we cannot add that. Now, there is one trick though. You may ask yourself, say, but wait a minute, what if I can turn that into a square root of 5, or I could turn that into a square root of 7? Well, in this case, there's nothing to do. We can't simplify it. So, I do want to change something to number 2. Let's pretend number 2 was something like this. I'm going to change it. I'm going to leave that one as a 3 square root 5. I'm going to change this one to, let's say, I'm going to change this one to, I'm sorry, I was losing my trail of thought. Make that okay? Square root of 80. So when you look at this initially, you might say, okay, well, that's a square root of 80. That's a square root of 5. Not like terms. I can't subtract them. I can't add them. Nothing. But square root of 80 can be simplified. Okay, so I'm going to show you guys how to simplify a square root. There's a few things that students do. There's a couple different ways of doing this. What I would like to tell you is this. Think of all the perfect square roots. Okay, so what are the perfect square roots? 4, because the perfect square root of 4 is 2. 9, because it has a square root. That would be a square root of 9 is 3. 16, that's 4 times 4. 25 is 5 times 5. 6 times 6 is 36. 7 times 7 is 49. And so on and so on and so on and so on. And I want you to think about the largest number here, okay? The largest perfect square you could think of that is a factor of 80. Meaning, which of these goes into 80? 4 does, because that's going to be 4 times 20. But there's a bigger one. 9 doesn't go into 80. 49 does not go into 80. 36 does not go into 80. 25 does not go into 80. 4 does. 9 doesn't. 16 does go into 80. So the largest of these two would actually be 16. So we're going to convert. You can just get a calculator, do 80 divided by 16, and you'll see that it is 5 times 16. I'm going to rewrite all this. Now, why is that significant? Well, here's why. Because now that we know it's 5 times 16, we can actually pull out the 16 from the square root. Because 16 does have a perfect square. The perfect square of 16 is 4. So that's going to come out. So out here, it's going to be a 4. And the 5 stays inside. So it's going to be 4 square root 5. And I'm going to rewrite the entire problem minus 3 square root 5. Now, if we look back, we say, wait a minute. Those are now like terms because they both have the same base, which is square root 5. So now we're simply going to go square root 5. We're just going to subtract the coefficients. 4 minus 3 is 1 square root 5. You can leave it like that. That's okay. I'm just letting you know you're never actually going to see it like that as an answer. Instead of 1 square root 5, you're just going to write down square root 5 because the 1 is invisible. Okay, so I'm going to do another one just like that real quick. To get a good example going. Another one just like that. What if I ask you guys to do a good one out here. Let's try one like this. Let's go square root of 12 plus 5 square root of, let's try that. Okay, let's try that one out. Okay, so first things first, that's a 12, that's a 27, that's a square root of 12, square root of 27, not like terms. But we can simplify both of these. Let's try 12 first. Okay, 12. Let me think of all the perfect squares. 4, 9, 16, 25, 36, 49, 64, and so on, so on, so on, so on, yada, yada, yada. I'm not going to do all of them right now. Usually one of these earlier ones. Sometimes we'll use these, but usually you're going to be one of these early ones. 12. 64 obviously doesn't go into 12. It's actually larger than 12. Okay, no. This is larger than 12. So is it 4 or 9? Well, 9 doesn't go into 12. So I know 4 does. It's going to be 4 times 3. Okay? Which one of these is a perfect square? That's going to be 4. 4 is going to go outside, and the square root of 4 is 2. So it's not the 4 that you don't put 4 outside, you put what the square root of 4. The square root of 4 is 2. So I'm going to put that as a 2. And what stays inside is that 3. So now we have 2 square root 3. Cool. Plus, now let's look at this guy. Guys, think about it. What can I do that what goes into 27? Does 4 go into 27? No. Does 9 go into 27? Yes, it actually does go into 27. But let me just make sure to check that the rest. 16, no, it doesn't go into 27. 25, it obviously doesn't go into 27, and these are just way too big. Okay? So the only one that goes into 27 is 9. So let's think about this. 27 is 9 times 3. Which one has a perfect square? Which one's a perfect square? That is 9. The square root of 9, when you bring it out, is 3. So I'm left with 2 square root 3 plus 3 square root 3. Voila! They now have the same base, which is square root 3. That means I can add them. The base square root is 3. That's cool. So now I'm just going to add the coefficients. 2 plus 3 is 5. That's it. That is absolutely it. Okay. Oh, wait a minute. I made a mistake. Okay. I made a mistake here. Yes, this was, I'm going to take this back a bit. Okay. I didn't copy the question right. That was square root 12 became 2 square root 3. This, however, had a 5 on the outside. Okay. And the 27 we said was 9 times 3. So let's see how this works. Okay, because this one had a 5 on the outside already. I forgot about that guy. Okay, so it's 9 times 3. Again, the square root, the perfect square root is 9. The 9 is going to come out as a 3. The square root of 9 is 3. But that 3 is going to come out, the square root of 9 is going to come out as 3. There's already a 5 outside. So what's the interaction there? Well, simple. Just multiply out. So 5 times 3 is going to be 15. So we're going to get, let me write that a little bit neater. So it's going to be, still going to be square root of 3, but now we're adding 2 plus 15, which is 17 square root 3. Okay, let me do one last one like that, and then we'll move on to the last problem and we'll be done. Okay, one final one like that. Let's do this. How about something like this? We can go 2 square root 12 plus square root of 75. Okay, let's try this one out. Okay, so again, all the perfect squares. We have 4, 9, 16, 25, 36, 49, yada, 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 yada. Usually we're going to be using one of these usually, okay? The earlier ones are the most common ones we're going to be using. So let's try this. I'm going to rewrite this as 2. Now, let's think about 12. 12 is going to be 4 times something or 9 times something? It's going to be 4 times 3. I'm going to simplify that. The 4 is a perfect square. What's a perfect square of 4? It's a 2. It's going to come out as a 2. But there's also a 2 outside already existing. So that 2 is going to multiply with the 2 and make a 4. What stays inside? 3. Now let's look, so I'm going to put plus. Now let's look at 75. 75 is going to be what times what? 4 does not go into 75. 9 does not go into 75. 16 does not go into 75. 25 does go into 75. Is there a bigger number than 25? I mean, 36 doesn't go in. 49 obviously doesn't go in, and that's already too big. So I know 25 goes into 75. So it's going to be what? 25 times 3. Great. Which one of these has a perfect square? That should be 25. 25 comes out as a 5. Now, in this one, there's nothing, well, when I say nothing, is there's no visible coefficient here. There is always a coefficient here. The invisible coefficient is 1. But this one had a 2, so I had to multiply 2 with the 2 that was coming out. 5 times a 1 is just 5. I mean, so when I say there's nothing outside, I mean it's just an invisible 1. Okay, so that's going to come out. So 5 is going to hang out there. And what stays inside is 3. Now I look at the entire problem. And I ask myself, well, okay, what's the like term here? What's the base here? It's going to be a square root of 3. That's cool. And I just add the coefficients. 4 plus 5, which is 20. And we are done. Okay. So that's the second video. That's it for the second video. I'm going to flip this over. You're going to see all the homework problems for this week, the week of 420. And it's going to be, so keep in mind, you guys, this is your YouTube. You're also going to see on Wednesday posted your practice test, and that's going to be a different set of homework problems. Okay, so here we go. Number 6, that's just like what we just did. Number 6 is a problem exactly like we just did. And number 5, I'm going to put a little star on it. Okay, haven't necessarily gone over number 5 yet. I just want to see if you guys can handle that. If you're not sure how to do number 5, you need to come to the tutoring session. I will go over that during tutoring session. Okay, 1 through 4 was from the first video. Number 6 is what I did. And number 5 is kind of like a challenge question. I want you guys to try that out, see what you can do there. And okay, that's about it for this week. Thanks, guys.